Welcome to queen7.com. Today we're going to look at how we can calculate the pH of the buffers. Buffers can be made by using the weak base and a salt like ammonia and ammonium chloride, or a weak acid and a salt, for example, any carboxylic acid along with the salt sodium carboxylate ion. You can look at how we can use the equilibrium expression. We are still going to use it while we're going to calculate the pH of the buffer. We have done that in using the weak acid and the bases, and we're going to use the same one again for the buffers as well. My request is whenever you actually calculate the pH, always try to focus on H positive ion. If you get to H positive ion concentration or moles, it's very easy for you to calculate the pH at the end. Now, when you look at this expression, we can actually use the same expression, which is H positive ion. The question number one is, you have a pH of a buffer, which is you have to find, you need to look at the volume and then your strength of that acid. So second part, you have the salt of that acid along with the volume and the strength. So you have a buffer of ethanoic acid and sodium ethanoate. They're both going to mix together with different volume and different strength, and we are going to find out the moles first. So first thing we're going to do is moles of ethanoic acid, which can be calculated by C into V, concentration into the volume. The concentration you have is 0.1 mole. You times it by 45. Because it is actually in the cm cube, make sure you actually convert it to dm cube, because we are going to calculate the moles per dm cube. You will get an answer of 0.0045 moles. Then you have the moles of sodium ethanoate, and formula is C into V again, and you have 0.15 times converting into dm cube by dividing by 1000, and you will have 0.05, and that will be 0.0075 moles. Let's take the expression of H positive ion, because H positive ion is actually going to lead us to calculate the pH. So H positive ion concentration is equal to Ka, which is 1.7 times 10 to the power minus 5. Then you have the concentration of Ha positive ion. Now, here is the confusion that we are actually using moles instead of the concentration. Basically, we are trying to calculate the moles and use the moles instead of concentration, because moles is a solute amount per liter. So that's why we're using the moles instead of the concentration. So 1 into 1.7, 10 to the power minus 5 is Ka, and then you have 0.0045, and you divide it by 0.0075, which will be 1.02 10 to the power minus 5, and that is the concentration of H positive ion. Once you find out the concentration of H positive ion, it's very easy for you to find out the pH, which is the minus the log of H positive ion concentration, and minus log of 1.02 10 to the power minus 5, and you will get a pH around 4.99. I did mention that before. Whenever you see a value of concentration with the value with 10 to the power minus 5, minus 3, your pH will slightly be less than the value raised to the power of 10. So if it's minus 5, so it should be around 4.8, 4.7, 4.6, or 4.99 in this case. Please share my videos again, and I will make sure that I will put some more examples. Thank you.